All right. Good morning, guys. I wanted to start you guys off with our next unit. And today we're going to be talking about the water cycle, also known as the hydrologic cycle. If you guys want to follow along with the notes, you can just go to the class documents from the MyCBA bulletin board and open up the notes. So what you'll come to is this, and then you go to notes, and then you go to Unit 6. So we're starting Unit 6 today. And you'll see there's two things here. These are the notes, and this is a document that we're going to look at together a little bit later on. If you want to print this sheet off, feel free. We're going to look at that a little bit later. All right, so I'm going to open up my notes right here and present this, and we'll just kind of walk our way through the water cycle. So I want you to notice something about the date here. The date is the 26th. Today is the 26th, but I looked last year. We did the exact same notes on this exact same day. So I'm like really excited about that because despite the fact that we're all home and this is all messing up our schedules, I'm still on pace, which is great. So let's start off with just talking about Earth in general. And when we do some astronomy stuff, we'll talk about this a little bit later on. Earth is very unique. We have water, as you guys know, and that water is pretty unique because not many other places actually have water. In fact, we're the only place that has water in all three phases. We have solid, we have liquid, and we have gas. And there's nowhere else like that. There are other places that do have water. Most of it is frozen. And there's really no other place that is unique like us. There's supposedly liquid water in a few locations, the moons of Saturn and Jupiter. There might be liquid water beneath the surface of Mars, but again, we're the only place that has it, and it's readily accessible. And interestingly enough, water is necessary for life, and so that's why life is here on Earth. And we could go into the whole theological ideas about this, but that's not what this lesson is about. So, why do we have water? Why do we have water in all three phases? And it's all due to the fact that we live in what's called the Goldilocks zone, also known as the habitable zone. The habitable zone is the more scientific term for the thing. So, what is the habitable zone? Well, it's being at a correct distance away from a star. So, your planet has to orbit a star, and it has to be a correct distance away from that star. And we just so happen to be a good distance away. It also is related to the size of the star. So if the star is too big, then this habitable zone gets shifted out farther. And our star just so happens to be the correct size, so not giving off too much heat, and we're the correct size planet at the correct distance away from that star. So this is called the planetary habitable zone, and we are right in that area. As you can see, Mars and Venus are a little bit too far away or a little bit too close. Now, we also live in what's called the galactic habitable zone. So this is a planetary system, right? We're talking about planets going around the sun. This is called the heliocentric model of the solar system, which we'll talk about. But we also live in an area around our galaxy. This is the Milky Way galaxy, our galaxy. And we live in an area around that galaxy that is called the galactic habitable zone. So in this area, we're pretty far away from other stars, so we don't have a lot of like collisions of stars. We don't have exploding stars, and so we don't have the dangers of being too close to like this mess in the center of this thing, black hole in the middle here, stars colliding with each other. It would be a major mess, and it would be difficult for life to exist in these areas. So we live in the galactic habitable zone as well as the planetary habitable zone. Now, despite the fact that we do have water on Earth, that water is not exactly, readily accessible. It's not all usable. 97% of the water on Earth is locked up in our oceans. Yes, you can desalinate, in other words, take the salt out of the water to make it usable, but that's expensive and not easily done. 2% of the water on Earth is locked up in the ice, so you got to melt it, which I guess we technically are kind of doing. We just talked about that, didn't we? But that ice, again, up in the North Pole and the South Pole, not easily accessible. And then the other remaining 1% is the fresh water that we use, and we'll talk about that in a second. Now, there is a video here that I'm not going to play, but if you guys want to watch this on your own, I'll give you guys a link to that video. It talks about the usability of water. So here's the distribution. You can see this is what I was just talking about. The oceans are a majority of it. Freshwater is up here in this tiny little bar. And then you have the glaciers that make up this little bit. We're talking about this bar broken down, right? So glaciers, about 70% of that, groundwater, and then surface water. So like all the lakes and the rivers and everything on the surface of the earth, all that water only makes up 1% of 2.5%. Now, if you break up that fresh water into like snow, like outside right now, weird, lakes, like, Lake Ontario, Lake Erie, the Great Lakes in general, they're in this tiny little percentage of this tiny little percentage of that tiny little percentage. So fresh water is a really, really small amount of all the water on Earth. Okay, now, obviously, that means most water is not really usable. It's not accessible or it's not usable. And therefore, we have to treat it kindly. And that's the whole point of a video that I'll show you later on. Now, check this out. This is a comparison of Earth to all the water on Earth. So we took all the water out of the oceans, out of the lakes, out of the rivers, out of the ice in the polar ice caps. All that water would amount to this little tiny ball compared to the entire Earth. And I always thought that's kind of a cool picture to compare the two of those things. Really, there's not that much water, even though you might think there is. Okay. This video, which I'll link you guys to later on, it's a TED Talk about running out of clean water, using water wisely. It's a pretty interesting and I think educational video that you might want to watch later on. Now, where did all this water come from? So there's some theories out there as to how did the water get on Earth? Why do we have water? Some of those theories from scientists include this idea of outgassing. Outgassing is referring to the idea that inside of the Earth there are gases and they spew out of volcanic eruptions and go into our atmosphere. And that's happening currently a little bit at a time. Now, some of those gases include carbon dioxide, nitrous oxide, but also a lot of water. Water comes out of volcanic eruptions, contributes to the atmosphere, and then precipitates out in rainwater or snow or whatever, and then falls down into the oceans. So that's one theory. So early on in Earth's history, the idea of volcanic eruptions happening a lot because the Earth was hot. And so you had all this outgassing that contributed water to the surface. That doesn't really explain where the water came from in the first place, but it's an idea of how it came to the surface. There's also a theory that, early on in Earth's history, it was getting bombarded by a lot of meteorites. We call these carbonaceous chondrites. And as they collided with Earth, the ice melted and formed most of our oceans on the surface of the Earth. But again, both of these are theories. They're not obviously known, no facts here. We're just guessing as to where it all came from. And this video right here is all about that. And I'll link you guys to the video a little bit later on. Okay. Now, moving on from there, we'll talk about the hydrologic cycle. So the hydrologic cycle is the technical term for the water cycle. So I might say both things, so in case you hear me say that. Anyway, the hydrologic cycle is this process by which the water on the surface moves around. And we're talking about into the atmosphere, on the ground, into the oceans, under the ground and groundwater. That's the process by which it's moving. And you guys probably learned this a long time ago when you were like in first grade. I'm teaching my kids about the hydrologic cycle, so I'm sure you guys understand it too. So it can be very, very simple, or it can be very, very complicated. In fact, there's processes that we really don't understand about the water cycle. You can start anywhere on this cycle, and we'll take a look at this a little bit later on, but the water is going to move around. So all the water that was here originally, from the beginning of time, has been here, and it just cycles around, which makes you think about it. Now, one major takeaway from this slide, and you guys got to understand this, the whole entire process of the water cycle, everything, all these water molecules are moving around from place to place because they have energy. And that energy comes from our sun. And that's important, that the energy of the water cycle is, the whole entire process is driven by the sun, warming up the water, making that water evaporate, and then condense, and then fall out. The whole process is driven by the sun. And if you can remember that, that's really the important takeaway today. Now, this is a chart that I'm going to skip over because I made a better one. This one has a lot of terms that you don't need to know. So I'm just going to skim through this really quickly. I also have it in letter form over here, which is fine, but I'm going to show you guys a better one a little bit later on. Okay, this chart, this picture here is kind of a cool one. It shows you the importance of water and how we use water. I actually have a poster in my classroom, which obviously you guys can't look at, but this is kind of cool. It shows you how we're using water and where that water goes, and how wasteful we are as Americans. So anyway, interesting. And now I'm going to go back to where I was originally. You guys had these notes, but there is this document here, this Word doc or Google Doc that you can print off if you want to. And I have it right here. So if you want to pause and print this thing, it'd be a worthwhile activity. If you can't print it, no big deal. You just follow along. And I have this document right here. And what I'm going to do is I'm going to go back to where I was. I had all these boxes covering it. Okay. And what I'm going to do is I'm going to go through this entire document, and you guys can fill out the boxes as we go. I'm just going to zoom in a little bit. We'll start at the top and work our way, kind of snake our way down through this thing. So let's start up here in the top left corner. You can see there's a big cloud here. That cloud, as you can see, is really tall. It's precipitating out here. But this cloud can, like, what we call evaporate. So the water that's here is all liquid water droplets. And those water droplets can re-evaporate back into water vapor that you can't see. So that process is an interesting one to start with, but that's evaporation up there. Now I'm going to move over here. This box over here is a box that has an arrow going up next to it, and that box is referring to condensation. So the big deal with clouds is knowing that the fact that you can see a cloud is because all of this is liquid water in its liquid form. And water droplets are making up this cloud. And we'll talk about that with meteorology. We'll talk about how clouds form and all that. But the big takeaway here is the process of going from from a gas back to a liquid, cooling it off, condensing it, turning into droplets. That's called condensation. Okay. Up here, there's a box that has an arrow going over. That's referring to this cloud moving across or through the atmosphere. That's called transportation. Interesting. But we transport these clouds around. We'll talk about how those clouds move a little bit later on when we get to meteorology. Now, notice this has a cloud with precipitation coming out of it. So that's referring to precipitation here. Precipitation can be in lots of different forms. Obviously, as you know, we just had some snow, but you can also have rain, you can have sleet, you can have hail, and all that water comes out of the sky in the form of precipitation. Now, this one's an interesting one. This is a glacial ice cap on top of this mountain, but you can see there's an arrow going up out of that ice into the air, and that's called sublimation. So sublimation is referring to the idea of going from a solid directly to a gas, and ice does sublimate. It skips the liquid phase. So does dry ice, which is frozen carbon dioxide. You may have seen dry ice sublimate. This box right here is going from that water vapor back directly into solid form, and that's called deposition, also known as desublimation. So it's the opposite process. That happens with frost on your windshield, frost in the grass, which you've seen probably on my Instagram video. All right, coming off these mountains, that process is called runoff. So it's melting, running off the land over the surface, and then coming into this lake or pond over here. Notice there's an arrow coming back out of that pond. That's called evaporation. That's a big one. Going from a liquid to a gas, evaporating into the sky. Okay. Down below that lake, there is a box that's going into the ground. And all of this area down here, this is all groundwater. And actually, there's a box over here that's about that. So we'll start with this one. This is called infiltration. Infiltration is the idea of water going into the ground. And we'll talk about that separately in a couple days. This is water that's going through the ground, and that process is called percolation. Okay, percolation is the idea of moving through the ground, and that's a little bit slow, and we'll talk about that a little bit later on. All right, over here, notice the water is coming out of the ground back into this systems, these are roots right there. That's called plant uptake. So water moving up the roots into the actual plant. And if you follow that tree all the way up here, there's a box above it, and that box is called transpiration. So we're taking the water out of the ground through the tree, and then the tree transpires, or basically it's also called evapotranspiration. It's the water going from liquid form into gas form into the air. So that's transpiration. Just remember tree, transpiration. Okay. Now down here below the tree, there's a box that is like running off the land. That's also runoff. It's kind of hard to see that one, but that's runoff right there. Okay. I skipped over this box. This is actually groundwater down here, because it's referring to the water under the ground. And now we'll go up into these last four boxes. So notice the water coming out of the ocean up into the air. That is called evaporation. Okay, so evaporating water from liquid form to gas form. This is the box that's referring to the rain coming off of this cloud. That's precipitation, liquid precipitation in this case. This box right here is referring to the idea of going from a gas to a liquid, and that process is called condensation. Just remember, clouds, condensation. And then some of this water doesn't actually reach the ground. And you might notice that sometimes you might have some dark clouds, but it's not actually raining. That's because the water is re-evaporating in the air. So that's evaporation there. So it doesn't actually reach the ground sometimes. Okay, so that's the whole entire picture. And if you take a look at the whole thing, you have everything filled out. Okay, so that kind of concludes our ideas about the hydrologic cycle. I'll have some more videos and things in the future, but I just wanted to show you guys all that, and hopefully that all makes sense. All right, thanks.